Hi, this class is to talk about hypothesis test for difference in means of two populations when you don't know the population standard deviation. Okay, so what we're doing, we're testing hypotheses about the mean difference between two populations, but we don't know the population standard deviation. So what we're going to do, we're going to use sample data, confidence levels, and t-score. The t-score, please pay attention to this. The t-score is used when you don't know the population standard deviation. So you have to understand, you have to know, you have to read the problem and figure out that you don't have the population standard deviation. Okay, so let's go. So here's the t, okay, and this is the difference between the two samples that represent, that are estimators for the two populations. So we are taking the difference between these two, and we are subtracting from a hypothesized difference. The hypothesized difference in our case is always 0. Okay, so this is how the hypothesized difference. So you can scratch that, and you only have this difference on top, and you divide by the standard deviation of the two population or the two sample means. Okay, let's take a look at one example. We have a company and they're developing a new computer software package, and the objective is to reduce the time to implement an information systems. So they have a new computer software package and they have the current software package. So they're asking for two samples of 12 engineers. So it's a sample of 24 analysts, 12 of them using the current technology. So this is the sample representing one population, and 12 using the new software package representing the second population. Okay, can we conclude using 0.05 level of significance, or alpha, that the mean project completion time using the new software is lesser, okay, than the mean project completion time for the current technology? So I want to show that the new software package takes less time. So this is like what I have to understand to be able to develop my hypothesis. So let me develop here the null and alternative hypothesis. So I want to prove that that the mean completion time is less. Is less for the new software. Let's get the current and the new. Okay, let's get here current and new. So if I want to prove, this means the alternative. Okay, if I want to prove that the new software takes less time, this means that the current takes more. Okay, and the null is that the new takes more time. So we always assume that nothing special about the new software or whatever. Imagine is a drug from a pharmaceutical industry. Okay, so this is our null and alternative hypothesis. I want to prove that the new software takes less time than the current, so the current takes more time. So this is the same thing as this. This is the same as the difference between them is smaller than 0, and the difference between them is higher than 0. Okay, so this is a upper tail test. How can I know? Because of the alternative hypothesis. The alternative hypothesis is positive, is higher than 0. How can I know that is positive, higher than 0? Because I started here, right? And then I moved this guy to the other side of the equation, and then I subtract, and then I have this. Okay, so I know that this has to be higher than 0. 0 is here, so I know that is an upper tail. Okay, so this is how you go from the problem to coming up with the hypothesis. Okay, let's take a look again at the problem. All right, so that's the problem. We have a summary statistics. We have the sample mean for the current technology here, for the new technology here, The standard sample standard deviation, take a look at that. Sample, it doesn't say population standard deviation. So because of this sample standard deviation, I know that is a t-score that I have to use. Okay, the t-score here, I have to compute this t-score, which is the score, the standardized score for the difference between these two sample means. Okay, so I have proposed the steps by steps to test this hypothesis. We have the approach 1, which is the critical value approach. So first step is develop the null and alternative hypothesis. Step 2 is determine if it's lower, upper, or true tail. I just did that. 3, specify the level of significance, and depending if it's lower, upper tail, or true tail, you have to do additional computation to be able to use here. So, okay, to get the t. And then after doing this, you compute the degrees of freedom. The degrees of freedom is computed using this formula. That's a very complex formula. You see that we have the sample standard deviation on this S, and we have the sample size on the ends. So you have to compute that. And then you go back here, then you use the alpha here in the probability, and the degrees of freedom here in this formula. So you are doing this 3 and 4 to get the t critical. Remember, this is a critical value approach. In the critical value approach, let me remind you. Let me draw here. In the critical value approach, I'm going to have a critical region. This is called critical region, where I reject the null hypothesis. Okay, so I'm looking for the t value that goes here and gives me the critical region. This is what we're doing. Okay, this is steps 3, 4, and 5. After getting the t critical, what you have to do is collect the sample data. This is given in the problem, and compute the value of the test statistic, which is this one here. Okay, then you compute this t score, and then you compare. You get the t statistic, and you figure out if the t statistic is here or is here. If the t is here, then you reject the null hypothesis. If it is here, along these lines, smaller than the t critical in this case, then you fail to reject the null hypothesis. Okay, so this is one approach, and this is the steps, very similar to steps for hypothesis testing when we have two population means and we know the population standard deviation. We have some twists here, which is we don't have the z-score, we have a t in our case that for this video. Using the p-value approach, the same thing, develop the null and alternative hypothesis, determine if it's a lower, upper, or true tail, specify the level of significance. In this case, for the p-value, don't have to do any other computation, and then you collect the sample data and compute the value of the t-statistic. That's the same step. And then you compute the degrees of freedom, the same step as before. And then, after getting the t-statistic and the degrees of freedom, then you find the probability for this t-statistic. And then if it's lower tail, this is the formula you used. If it is upper tail, that's the case. You do this formula. If it's true tail, you do both formulas, choose the smallest value and multiply by 2. And then you compare the p-value you found with the level of significance given here, okay? That's the steps I'm going to show you in the next videos, okay? So this is basically what the steps are. And here's the summary of the hypothesis. If the alternative hypothesis, the difference for the means in the alternative hypothesis is less than 0, always replace this hypothesized difference by 0. Always replace by 0, by 0. You replace everything. D0 means 0 in our case, okay? So if the difference in means for the alternative hypothesis is 0, and this difference has to be smaller than 0, then it has to be left tail because it's a negative number. If this difference is higher than 0, then it's upper tail, like in this case, because it's a positive number. And if we have a problem that asks for the difference, then it's a two-tail test, and this is the test statistic. I'm going to stop here and come up with a video for an application in the next video, okay?